So here are a couple of explanations for problems on the 8.4 Think IB question, strong acids versus weak acids. This is number 2. Number 2 says, explain why nitric acid and hydrochloric acid have the same value for the enthalpy of neutralization when they react with sodium hydroxide solution, but the value is different for the neutralization of ethanoic acid with sodium hydroxide solution. So first and foremost, enthalpy of neutralization just means how much heat is released when an acid is neutralized by a base. And I pulled up here your Ka table that you found on the slideshow. And if you notice at the top part of the Ka table, here's hydrochloric acid, here's nitric acid, and they both fall under the category of very strong acids. That means they completely dissociate in water. The Ka value is much, much greater than 1, and the pKa value is much, much less than 1, which means that when you throw one of these strong acids into water, they almost 99.99% dissociate into their ions. That means also that the reaction is going to be quick and a lot of heat is going to be released. However, acetic acid is the same as ethanoic acid. When acetic acid is thrown into water, the Ka value is less than 1 and the pKa value is going to be greater than 1. This indicates that you got a weak acid, so not all of the ions will dissociate into water, which means that you won't have a fast rate of reaction, and also not as much heat will be released. So when you're answering the question, basically this question is asking which ones are the strong acids and which one is the weak acid. And the strong acids, the chloric and nitric, the weak acids, the acetic, and that's why the enthalpy of neutralization will be different. And here's question number 3. When solid sodium ethoxide is dissolved in water, sodium hydroxide and ethanol are formed. From this observation, deduce whether water is a strong or weaker acid than ethanol. I'm going to rewrite this equation briefly, and I'm going to do this by, I really don't care about sodiums. Sodiums are spectator ions. They hang out and do nothing. So I'm going to rewrite this equation in terms of the active ions, which is going to be my ethoxide, and my water, but look how I am spelling out water. I'm spelling out water in terms of HOH. And I am going to, in this solution, have active ions of hydroxide and active ions of C2H5OH, which is your ethanol. So, looking at this in terms of who is donating the proton, you can see that what happened here is the hydrogen from the water donated its proton to the ethoxide. And that's how you ended up getting the C2H5OH. There's my conjugate acid. My conjugate acid there is going to be my ethanol. My conjugate base is going to be my OH with a negative charge. Now, water decided to donate a proton as opposed to the hydroxide accepting a proton. That tells me that water has to be a stronger acid than the ethanol that's created because the ethanol was formed from this reaction. Now, notice the arrows here. The arrows, I got a long one on top. The long one indicates that equilibrium is going to lie to the right, but I do have a kind of medium one on the bottom that some of these ions here will redonate their hydrogens to the hydroxide in order to remake water. But equilibrium will definitely lie to the right, and definitely in this case, water is a stronger acid than the ethoxide.